For our second video segment in the fan test and lab session, I'll go over the setup and the instruments in more detail. And to keep it simple, I'll start at the close end here and then work our way down the wind tunnel. On the table here, we have two manometers set up to record the two different static pressures that we talked about in the first video segment. One is labeled delta P, and this is the static pressure at the inlet section of the wind tunnel. And this is going to be used to calculate the flow rate Q based on the equation from British Standard 848, which we will include on the data sheet. The second manometer is labeled P sub S, and this is the pressure recorded downstream from the flow restriction box. And once again, this will be P in the P versus Q plot for the fan, just the fan curve itself, and it will just be plotted directly. For both manometers, the pressure taps from the wind tunnel are connected to the minus or negative pressure taps on the manometers, and then the positive pressure taps on the manometers are left unconnected. So we will be reading a negative pressure in the wind tunnel compared to the ambient pressure in the lab. Both manometers are set up to record pressure in inches of water, and we will use them in the averaging mode that we talked about in the last lab session at the airflow demonstration unit. Also at this table, we have a clipboard with a data sheet on it, and we'll go over that in more detail in the next video segment. And then we also have a laminated sheet that tells us which flow restrictions to use depending on which fan or fans are being tested. And this sheet also indicates the speed settings for the low and higher speeds that we will test. The speeds are controlled with the control pendant for the variable frequency drive, the VFD. This is what you used in the very first lab session for the anemometer calibration lab. And this time though, we're going to be using this small display to record some additional data from the VFD for the electrical characteristics of the fan. Specifically, we're going to record the voltage, the current, and the power factor. That will allow us to calculate the electrical power consumed by the fan. And then in your analysis, you will compare the electrical power consumption to the aerodynamic power of the airflow, and from that you can determine the efficiency. What we generally find in our lab is that the fans operate at nearly a constant electrical power, and so the efficiency increases as the aerodynamic power increases, and we will discuss that in more detail later. Okay, bear with me now. I'm going to move down the test stand to the flow restriction box, and I've got to set up the tripod there, so just bear with me for a minute. All right. A lot of obstacles here. Okay, hopefully that'll be a good enough view. So we have three different types of flow restrictions that we will use in this lab session. The most common one is an M, designated an M for mesh. We've got 5 of these, so it's a rectangular mesh. M5 is the largest, so larger number means larger opening. This is M5, it's the largest opening. Conversely, M1 is the smallest opening. So you can see that M5 is not very restrictive. M1 is quite restrictive. These flow restrictions fit into this box here, so we have a foam sealed lid on the box. We just put the restriction or restrictions, depending on what we're after, in here. Put the cover on. It takes a little bit for the flow to equalize, but then we just take our data point. Very simple. The second type of restriction that we use is cut out from plywood. We're just going to use one of these. This one is designated B3. And then the third type of restriction that we use on this wind tunnel are R, designated R for round. These actually fit directly within the duct here, and they rest on some small tabs that are welded to the surface. And again, we just use the R4 for this lab session. Okay? I wanted to show these to you because you're going to see these designations on the data sheet. You'll see M1, M2, M3 plus M2 combinations, and now you'll have some context as to what those mean, okay? Okay, now bear with me again. We're going to move to the far end of the wind tunnel so that we can see the laser tachometer for measuring the RPM. All right. Here's our bagline network. Okay, we have a trouble light set up here so that we can see inside the end of the fan here. So this is the laser tachometer. This is the only instrument in this lab session that you haven't used before, but it's fairly simple. To use it, you aim it at a reflective target, such as a piece of reflective tape on a fan blade, old broken fan blade here. You push a button and that illuminates a red dot, a laser, and you just aim this at a rotating target. You'd have one piece of tape for the whole rotor, and the way it works is that the laser light is reflected back when it encounters the reflective target. The instrument measures how long that takes in a very simple calculation to give you revolutions per minute, or RPM. It's a little bit tricky to use because you can't really see the target when the fan is running, and also the reflective tape is on a curved surface of the fan blade, so it doesn't necessarily bounce directly back at you. But with a little practice, it's a very reliable instrument. I'm going to take the camera off the tripod and show you where the tape is on the 10 horsepower fan, and it's very similar on the 2 5 horsepower fan, so we'll just take one look at it here. What we do in the labs here is we mark a spot on the safety grill at the fan discharge here. We're going to use that to line up the instrument. We're going to try to keep the instrument parallel to the axis of the fan, and that will line it up with the tape. So we'll take the camera off here. Okay, so here's the safety grill, and you can see right there outlined in felt pen is where we're going to line up the tachometer. And then as we put the camera in there, you can see off in the distance there, you can see a piece of reflective tape on a single fan blade. Okay, so now we'll grab the instrument. We put the instrument in that spot on the grill, and then we line it up parallel to the axis, and lo and behold, the dot is reflecting off of the tape. Okay, so again, it takes a little practice. There's a steady breeze, quite a breeze blowing in your face from the fan, and you're wearing safety glasses, and it's noisy, but it works out pretty well. Okay, we're almost done with the second segment for the fan test stand. I just want to show you the pressure taps and the duct in a little closer detail. Here are, again, the pressure taps for the P sub S, the fan pressure, and we've got 4 little tubes equally spaced, welded to the duct. They are connected to one another by T's, so they are giving us an average of all 4 pressure readings. And the tubing runs up and across that bridge there over to the table where that manometer is. And then at this end, we have the exact same situation for the delta P measurement. Again, the delta P measurement is going to be used to calculate the flow rate Q, and the P sub S measurement is simply the static pressure that the fan is generating. I also wanted to show you the inlet bell here a little more closely. So this serves to reduce the shock losses into the wind tunnel. Again, we talked about that in the airflow demonstration unit lab last week. And finally, here's a view looking down the axis of the wind tunnel. You can see it's just a very simple duct with a box in it and some pressure taps. So this is something that can be easily fabricated to keep on site at a maintenance shop. Okay, that's it for this second video segment, the tour of the fan test stand. In the next segment, we will look at the data sheet, and then we'll be ready to take some measurements.